What is probability?
Probability refers to the likelihood or relative frequency for something to happen. The continuum of probability falls from impossible to certain. When we speak about probability or chance, we are referring to the odds of an event occurring.
For example, you may hear the weatherman make a prediction of an 80% chance of rain. Better not hang that washing out. 80% means that it is highly likely that it will rain.
The language of probability starts as early as kindergarten and continues throughout one's life.
It is important for students to understand the terminology of probability, both qualitative and quantitative. For example, we can say the chance of me going to Disney World tomorrow is unlikely, but the chance of there being a thunderstorm tonight is 30%.
The 2013 New South Wales syllabus states that it is important to explore probability through experimental learning experiences from Stage 1 through to Stage 3. In particular, Stage 3 requires students to conduct chance experiments and assign probabilities as values between 0 and 1 to describe their outcomes.
Andrew supports this notion as she suggests that the concept of probability can be more readily understood through experiments, as they encourage students to develop understandings of probability grounded in real events rather than working out answers based on formulas.
So, why is it important for students to understand probability?
The importance of students' understanding of probability has grown out of societal needs, with predictions being extremely important and useful in everyday life.
From making predictions about weather, to health, to their chance of winning the lottery, and maybe getting a treat after dinner, students need to understand probability.
So, can you explain some concepts within probability and maybe some misconceptions that students may have about them?
Sure. When assessing the probability of an event, it is important to keep in mind that events are independent of one another. For example, each new toss of a coin is not connected to the previous toss. Students are often confused by this concept, as they expect that after tossing 3 heads, a tail must be the next to come. Shaughnessy describes this concept as representativeness, and for children to gain a full understanding of probability, it is essential they understand the notion of independent events.
Another well-known mistake that students commonly make is to think that when rolling a dice, a 6 is less likely to come up than other numbers. After years of playing board games and sitting around waiting to roll a 6 before being able to start, students may begin to think that rolling a 6 is less likely to occur than rolling another number. Once again, Shaughnessy supposes that this arises from the availability heuristic, meaning that students base their probability estimates on their most accessible memories, which, going back to our board game scenario, makes sense.
So, how can we teach these concepts to children?
Well, as mentioned earlier, experimental learning is valuable as students can see firsthand that tossing a coin is a series of random, independent events that are not connected to one another. They build on their previous memories, creating new ideas about probability. It may be beneficial to tally results so students have a visual representation of a sample.
So, what are the chances you understand probability now?